Hello, welcome to Econometrics Melody. In this tutorial, we'll deal with 5 two-way scatter plot types in Stata. So the plot types are rscatter, pcscatter, dot, dropline, and rconnected. We have already covered the scatter plot type in our video number 7. Please refer to that video. Let us prepare our data. And the first plot type for today is rscatter. R stands for range scatter, and this will be evident by a graph. So rscatter of import, export, and income. Here income is the last variable, so it acts as the x variable, and rest of them are the high and low variable, or the high low variable, or maybe the confidence interval, or maybe some range variables. So this is clear by the graph rscatter. We can get the same graph by the help of a scatter graph as well, and if we see it, so this represents the high value and this represents the low value, or maybe the upper interval and lower interval, and we have a specified marker size 33 for both the markers, both the y variables. And if we take the same pstyle, then we'll get the similar result to that of rscatter. Again, we are going to plot the scatter plot type, but this time we are making use of pstyle p1 and p1. So there's no difference except the legend. We can also opt the legend. Now if we combine these three graphs that we have just displayed, they are similar. So we can always get the rscatter plot by injecting some, or by using some styles of the scatter plot type. So this is all about two-way rscatter plot, and we can always use these options, make use of these options, which are very common options: vertical, horizontal, marker options, marker label options. We have seen these options in our previous video. Now let us move to the next scatter type. It is pair coordinated scatter type. For this, in order to plot this graph, we need to have 4 variables representing y1 x1, y2 x2, and let us look at this. So 4 variables: y1 x1 the first coordinate, y2 x2 the second coordinate, and if we plot, or if we specify pcscatter and the 4 variables, we'll get this result. So these points are plotted actually. Now let us see one of its feature. If we specify mlabel, label education, so y1 x1 will be labeled. So we have labeled it by education. So the point y1 x1 will be labeled. It's for example 24 and 25. So here it is 24 UG, and 25, this value is 25. Otherwise 0 and 1. So if we say this is 0 and 1. But if we want the second y2 x2 to be labeled, then we need to specify this option called headlabel. Now we see the x2 y2 or y2 x2 value is labeled. So 26, 27, y26, x27, y26, and x27 UJ. And if we combine this, we'll see how the values are set off. So this is without specifying the head label. Simply we have specified mlabel. By default the x1 y1 will be labeled, and if we specify head label, x2 y2 will be labeled. Now let us move to the next one. Again, we have used 2. If we want both the x1 y1 and x2 y2 to be labeled, then we can draw the pcscatter of the same variable 2 times and specify head label to the latter one, and we'll get our desired result. Now both the x1 y1 and x2 y2 are labeled. We have differentiated for distinction. We have differentiated the first label education variable is education, and the second label variable is district. Undergraduate, graduate, these are the education, and district ABCD is the district. But we can attain the same result by making use of scatter graph or scatter plot. So we have taken the x1 y1 x1 variable. It's a first scatter type plot, and the second scatter is y2 x2, and then for their congruence we have specified the p style. So we have a same p style, same color. This is the same graph, and if we combine it, this will be clear. So we have used pcscatter for this, and here the second one we have used a scatter plot. Now we can specify any 4 variables, not x1 y1 x2 y2. We can have any 4 variables play this role of y1 x1 and y2 x2. So let us use import, income, export, and income. Let us see, this is the result. And again, if we plot, we want the second variable to be labeled y2 x2, then we can specify head label option. This is a kind of a reinforcement, and if we compare it, we'll see the result. The second one, we have specified head label. Now let us drop all the graphs. We can always drop the graphs that we don't like the name, or we can drop all of them. Now let us quickly move to another two-way plot type. It's a two-way dot plot, and let us see it by the help of example. So it is a scatter plot, two-way scatter of 2 variables, input and export. And if we write two-way dot, if we replace scatter by dot, we get this result. So the scatter or the markers, so beyond and above it, we notice the dots. And so this is a dot plot type. And these are the options, very simple options. Now we can manipulate the look and feel of these dots, and these are the options: base, number of dots, dot style, symbol, and so on. So if we specify dot, 2 variables, this is the simple graph. If we specify horizontal, we'll get a horizontal graph. And if we specify dotextend, yes, so this is the default one. Dot will extend beyond or above the marker. And if we specify dotextend no, you won't see any dot won't extend beyond that marker. And if we specify base 3000, so our base of this graph should be 3000. Here it's 9000, and this should be somewhere 3000. And we can also manipulate this. If I specify bits to be -500, we will see the difference in the scaling of y-axis. So this is -500. And if we specify number of dots to be 21, we want these dots to be 21. And if we count all the dots, there are 21 for each marker. And the dot style is a p2 style. So we have seen in our previous video, we have p1 to p15 styles. Please refer to video number 7 for that. And we can also manipulate the symbol of the dot. We want plus, this is the plus sign. And we can always manipulate the color, size, and width of the dot. Now let us combine and see it for ourselves. So the titles will help us in understanding the options that we have specified. Dot is a normal dot, horizontal, dot extend yes, no, base 5000, and base is -5000. And here number of dots to be 21. And if we combine the remaining graphs, dot symbol, dot symbol plus p2 dot style, this is the overall style. And here we have manipulated the color, dot size, and this should be a triangle. The dot symbol is triangle, length width is 0.5, and so on. So we can always drop the graphs that we don't require by using this command graph drop all. Now let us move to another plot type. It's a drop line plot types, and it is very, very simple. So we get a very beautiful graph out of it. So from the marker, a line drops towards the base. So we can get the same result. We have specified drop line for this, but we can get the same result by this dot graph, two-way dot graph. And let us see it for ourselves. Similar result. And we can always manipulate the dot style. had we specified its dotextend, and let us compare it, and they are similar except the vertical line. And these are the options that we can use for drop lines: vertical, horizontal, and base. We have already dealt about it. Marker options and marker label options, line options, axis options, and two-way options. Let us see some of them by the help of example. Let us create the difference of certain variable. We're going to draw the drop line graph of this difference variable and symbol number. Weight is income, and let us see what does it look like. So the size of the marker are different. They are proportional to this income or the weight variable over here, and they all are based to this 0. Let us see another example. This is again, we got the same result using dot instead of drop line, and if we combine it, this is clear. This is the kind of reinforcement and repetition. Now let us label them. So we have labeled them, and we have used drop line for this, and if we use dot instead of drop line, we'll get a similar result. And if we combine it, the result here, the first plot we have used drop line, the second plot dot, and let us drop all of them. Let us see our example 2. What is it about? It is about plotting the residual term, residual plot. So by regress these variables, predict the residuals, and let us use our drop line, and we will label it by the symbol number, and we want to see which number is contributing in this differences, or which observation is an outlier. So this is the base. We could have drawn y line is equals to 0 over here. So let me do that. If I write, and if I specify y line at 0, and then we can have given it color to be any color, let's say red, so it is easy for us to differentiate. Option color not allowed in, so L color red. So should we specify L color red for this? And if we write this, we'll get the result. Now let us drop them all. So we have used drop line. Instead of drop line, we could have used dot. Can we replace it? Let us see it. And oh my god, we can't do that. So and that we could have done that, but dotextend dot ext and no. And let us see whether we'll get our desired results or not. This is a similar result, and let us drop them all. Now let us move to another plot type, rconnected. R stands for range, high, low, and the upper, lower, minimum, max, confidence interval, and so on. By this time, now we'll get a connected graph. This is simple. Please refer to the connected plot type. So this is the connected plot type, and L pattern dash, and the marker symbol is circle but hollow circle, and we have used R connected. We can get the same result by binding two connected plots type, and we'll get the same result. And if we combine them together, we won't see any difference. And we have specified the pstyle as well for this uniformity in the color, and they are not different, they are same. And these are the options we can explore: connected options, marker options, and marker label options. Now, before we leave, let us try to remove x-axis, y-axis, and its labeling completely. And here are some of the ways. If we specify, the title will help us in understanding x scale off, y scale off. This is the result. And if we specify x scale off, y scale off, y label none, an X level node, we get this result. We don't see the axis, and if we specify X Y scale no line, we don't see any line, but the title, X title and Y title are there, and label none. If we don't want this title of Y and X, we can specify Y title empty or blank by 2 quotation and import similarly Y title blank. And let us say the another one. So the plot region style is none. That is why we don't see any white color. By default, the plot region have white color. And let us combine them and see it for ourselves. So both X and Y scale off, we get this result, but the growth line appears from Y. So we can also off this growth line. Here we have to label none, so we don't have any label. Now let us see the other one. So the plot region, it's by default it's white in color, and we have switched off and we have not taken any styles. So that is why we get this default style. This is it for this tutorial. Let us drop all the unwanted graphs, and this is it for this tutorial. It's a time to thank you all for your precious time. Thank you very much for your time. Thank you very much, Econometrics Melody.